So let us first of all talk about condensation or step growth polymerization now. In this video, we would be talking about the second type of polymerization reaction. The first type that we did was addition type of polymerization reaction. Now we take up condensation type of polymerization reaction. This is also called step growth polymerization. And why is it called step growth polymerization? We would also be talking about that. So this involves, repeated condensation reactions of same or different types of bifunctional or trifunctional monomers. Bifunctional would mean monomers having two functional groups, and trifunctional would mean monomers having three functional groups, right? So this type of condensation, this is a kind of condensation reaction, and it involves same or different types of monomers, but these monomers have to be bifunctional or trifunctional, right? Also, you have to know that such reactions may also lead to simultaneous loss of small molecules like water, alcohol, hydrogen chloride, etc. So this is one more thing that you have to know, that such reactions may also lead to some loss of some small molecules, right? And also at every stage or at every step, the product which is formed is also a bifunctional product or a bifunctional species, and so the condensation reaction may continue. So at each step, the product formed is also bifunctional. And hence condensation can continue. Basically, when there are two monomers combining and undergoing some condensation reaction to give a bigger structure, a dimer, two monomers combine and give you a dimer. The dimer which is formed can continue condensation reaction only if it has got two functional groups, right? So the polymerization reaction can continue only when your product formed at every stage has at least two functional groups. Only then the reaction continues, the chain continues to grow. Otherwise, the polymer would not grow. So this is very, very important, that the product formed at every stage is also a bifunctional product. And now the last part, why is it called a step growth polymerization? The reason being here, at every step, you get a distinct product which is produced, right? There are no reactive intermediates generated, but at every intermediate step that occurs in the process of polymerization, at every intermediate step, you find that there is a distinct, functionalized species, which means an individual molecule gets formed, and it is independent of all the other products which are produced during various stages. And so this process is called step growth polymerization, because the polymerization reaction occurs in steps, and each step has a product involved, not a reactive intermediate. And thus, this is step growth polymerization. So this is in general, what we understand about condensation or step growth polymerization, right? The basic steps are all, condensation reactions. Condensation reactions always involve loss of some small molecules like water, alcohol, HCl, etc. Every stage or every step in this process involves a functionalized species, and because at every stage there is an independent functionalized species involved, we call this as step growth polymerization. Now let us take up some important condensation reactions. The first one we take up is called polyamides. So let us talk about polyamides. First of all, polyamides have amide group which gets repeated, right? So in these polymers, amide group gets repeated, right? And generally they are formed by monomers which can be diamines, which condense with dicarboxylic acids. To form polyamides. You may even find that many a times lactams are basically cyclic amides. Lactams can undergo condensation to form polyamide type of polymers. Right? Now, let us first of all understand which polymers fall in this category. Now, you must know that there are two important types of polymers which fall in this category. One being nylon 6,6 and the other being, just a moment. Yeah, one being nylon 6,6 and the other being nylon 6. So let us start with nylon 6,6. The first and the most important polymer that falls in this category of polyamides is nylon 6,6. Nylon 6,6 is obtained by polymerization of two different types of monomers. This is called hexamethylene diamine. CH2 group is a methylene group, so hexamethylene diamine, and this is like a dicarboxylic acid which we call as hexane 1,6-dioic acid. I don't have any space to write, but I can put it here. Hexane 1,6-dioic acid, right? So and this is your nylon 6,6, the polymer, right? Why is it called nylon 6,6? Because each monomer contributes by giving 6 carbons to the polymeric chain. So each one of them would give 6 carbon atoms to the polymeric chain. So it's called nylon 6,6. This is also a copolymer. So you must remember that it is a copolymer because there are two different types of monomers, right? Now, if we talk about the properties, right, let us talk about the properties and uses now. So some of the properties that we can talk about, right, are like it's a linear polymer. Fibers are hard, strong, and even water resistant. So very, very strong, high tensile strength it has, and it is basically a thermoplastic. Now you have to know that these type of fibers, they form a very closed pack structure. They form a very close packed structure, and we also call this as, the polymer attains crystalline form. Now, why would this polymer attain crystalline form? That's because between the two polymeric chains, there are strong hydrogen bonds. Now, how do we understand these hydrogen bonds? Look at this. this is the amide link of one polymeric chain, and this is the amide link of another polymeric chain. You can see this. So between oxygen of 1 and hydrogen, oxygen of CO group belonging to any one of the polymeric chains, and hydrogen of NH group of another polymeric chain, there are strong hydrogen bonds. What are these called? This is H bond. This is also H bond. So between the polymeric chains, there are strong hydrogen bonds, which is the reason why the tensile strength of these fibers is very, very high. They form a very closely packed structures, and they attain a crystalline form, a perfect geometrical arrangement, which is generated through intermolecular H bondings, right? And so now we go to the uses. Where are these fibers used? Right, so we can talk about the uses. Here we say that the fibers, they are used for making bristles of brushes. They're used in textile industries for making fibers. Right? And they're also used for making, sheets. All this, making sheets which are made from nylon sheets, bristles of brushes, they're also used in textile industries, etc., etc. So nylon 6,6 is a very, very important copolymer which is formed by condensation polymerization. When we talk about nylon 6, first of all, it is called Perlon. This is the second type of polyamide that we have to do. This is a homopolymer, so it has only one type of monomer. The monomer is called caprolactam. Lactam indicates it's a cyclic amide. This is your caprolactam, has 5 CH2 groups, and it is a cyclic amide. This has been hydrolyzed at using a temperature of about 533 to 543. The hydrolysis occurs here, and then the polymer gets formed due to condensation. This is nylon 6, the formula, right? And you have to know that this is also very similar in properties to nylon 6,6. Let us now check the properties and uses of this polymer. So now let us discuss the properties. These are linear polymers, and again, due to polyamide type of polymer, it would always have intermolecular H bonds. So the fibers, have very high tensile strength. They are very strong. This is thermoplastic, and it is water resistant. So in the end, we have the uses. 3 important uses, because these fibers are extremely strong. They're used for making ropes and even the fishing nets, making tires. I'm sorry for the spelling, in just a moment. Tires, and then they're also used for making carpets. So that's it. So just have a look at nylon 6, the preparation and the properties and the uses. The preparation is very important because you have only one type of monomer involved. We call it as homopolymer, and the monomer used here is caprolactam. As I've told you, that lactam would mean a cyclic amide. Here it has 5 methylene groups, CH2 groups, and it's a ring. And properties are very, very similar to nylon 6,6. All right. So in the next video, we would talk about polyester type of condensation polymers. Okay.